So the IMA is a very good partner for Sprint. We look to the IMA to scout for us for looking at companies in Israel. We obviously don't have an operating presence there, but it's a very important partnership for us, and it's one that's formed over a few years now, and it's getting stronger and stronger. And it's good to see IBM involved as well. IBM is also a very important partner for Sprint here in the US. I should say here, we're in Barcelona, I guess. They're in the US. And then also Alcatel-Lucent is also a partner of ours who are also partnering with the IMA and putting a lab in place in Tel Aviv, and we're connecting that back to Kansas and being able to set up facilities there in Israel that allow us to do some testing there as well. So that's very important. So LU is also a very important partner of ours going forward as well. So what I thought I'd do is kick it off a little bit talking about where we are today as Sprint and what we're doing in our network. And something we've been talking about over the last several months is Spark. I'm going to go through a little bit about what that is and what it isn't, and what does it really mean for the competitive landscape in the US, and the relationship that we have with SoftBank and Clearwire, what we're doing with our spectrum. And really, the message that I want to give you is the network that we're building is really, frankly, changing the landscape. And we're really very interested in how applications, content, technology can take advantage of the spectrum depth that we have and the capability that we're building in the network. You know, if I look back over the years, whether it was the introduction of GSM or TDMA or CDMA or WAP or GPRS, we always had the networks well in advance, and the network technology was always in advance of the devices. And we're seeing something similar here. So we're going to talk a little bit about what we have in terms of the capability, what we're deploying in terms of the radio technology, what it does in terms of the network capability, and then we're also working on the ecosystem of devices, but we also need products and services that take advantage of this capacity as well. So the tagline is, it takes a network, because it doesn't matter who you are, any service provider that's taking advantage or any app provider that's taking advantage of the infrastructure really needs a network in order to create the utility and the value there. So we see it as foundational. Here's the standard safe harbor, which I hope you all read. But I will be talking about some stuff that's forward-looking here, so I want to make sure that we make the necessary disclaimers on this one as well. So just to level set, network vision, you know, it's really well into its deployment right now. We've talked a lot about this publicly. We're really coming towards the conclusion of this, and network vision really is you know, dare I say it, a rip and replace of the existing network that we've had for some time. It's a rebuilding our 3G network as well as our 4G network. It's a multi-modal platform. It basically supports 1x advanced from a voice perspective, DO. It's multi-frequency, support 800, 1900 as well as 2.5, and I'm going to talk a little bit about the 2.5 build-out and the deployment that we're doing. What's really important to us is that you can move between the different frequency layers, and you can move between 3G and LTE, TDD and FDD seamlessly, and that's very, very important from a customer experience perspective, and it's something we spent a lot of time working on. We completed 200 million LTE POPs, which was very important for us to get as a milestone at the end of last year, and by mid this year we'll be substantially completed through our network upgrade, which is really the foundation for us going forward. And we're really talking about sort of Sprint Spark, which is a combination of these three frequencies as well as what we're building on top of that as well. And the 2.5 spectrum depth that we have really well in excess of 120 megahertz of spectrum per market in 2.5. And so we're lighting that up on top of our 1900 spectrum as well as our 800 spectrum. So I'll talk a little bit about that. But that depth of spectrum, as well as the high frequency capability of that, or the high frequency nature of that, gives us a lot of capability in terms of tonnage, speed, and throughput. And I'll talk about that as well. So we often get asked about sort of the SoftBank, Clearwire, you know, deals that we did, and just to touch on this, SoftBank is a very important partner for us. They own 80% of the company. It was a very strategic investment, but much more than a strategic investment. It's an operational partnership we have with them. There's a lot of technology transfer. They have a lot of interest in 2.5 and deployment of TD-LTE in Japan. And so there's a lot of information sharing and technology collaboration in terms of that ecosystem that we're doing there. Clearwire is obviously very important to us, and you know, we didn't have control of Clearwire. The investment of SoftBank in Sprint allowed us to take control of Clearwire. So bringing all of that together was very, very important, and hence the way I characterize that in terms of a Venn diagram. When we put that together, though, there was a lot of questions around, well, so now you have Clearwire, what does that really mean? What are you going to do with the spectrum? and that's when back in October, at the end of October last year, we announced Sprint Spark, because it was really a culmination of activity that's been in the works for a couple of years now, to really show what can we do with the spectrum, together with the partnership with SoftBank, the technology relationship we have with them, and then what can we launch in the US. So that was very, very important. So that's what led to Spark. So this is what I like to say. Some people talk about megabits per second, we talk about gigabits per second. And it really is, remarkable what we can do. So back in October last year, we actually showed over the air with Samsung, we can do 1 gigabit per second on a single sector. It's the peak sector throughput. We'd set that up, we ran it through a system. And in fact, one of the challenges we had was pushing enough traffic over it to be able to take advantage of the spectrum. We actually were running 4K Ultra HD content through over the air, and that wasn't enough, it was sufficient enough to actually consume all the capacity, so we ended up pushing more and more traffic in parallel over that. If you haven't seen 4K, I mean, you ought to go check out some of the stands here, but it's absolutely fantastic in terms of the quality of the content. And I wouldn't do it justice showing the video here, but we actually ended up, even then when we were doing it, we had some challenges getting source content. So we actually worked with NASCAR, who's a very important partner for Sprint. We actually went out with NASCAR, filmed a bunch of content to be able to run it through and demonstrate that over the air and over the network. In fact, one of the cool demonstrations that we did with this was we had actually a liquid tablet. We worked with Qualcomm where we had 360-degree camera angles. And so we're able to take in the content 4K, Ultra HD on 360, and you'd actually be able to rotate the tablet and look at different viewing angles on the track from the car or even from the side of the race. So it's really fantastic what you can do over that network. What we also did with Samsung, we had 1 gigabit per second over the air on a sector. With NSN, we actually showed 1.3 gigabits per second over the air, not over the air in this setup. We had the 1.3 running through 60 megahertz of spectrum. We had it configured up on multi-carrier carrier as well as a very high order of MIMO to be able to demonstrate what we can do in terms of throughput with 60 megahertz. And then I'll show a video here in a little bit, but we actually doubled that up to 2.6 gigabits per second now, using 120 megahertz of the spectrum that we have. And so even with 120, we still have additional spectrum we're not using in most of the markets. So getting it up to those kind of speeds is just phenomenal on a sector basis. So if you look at a cell site, we're talking about delivering really close to 7+ gigabits per second on a cell site, which is remarkably greater than anything that anybody's deploying right now. The other thing I should make a comment about is, we often come in for some criticism about, well, this is cool to see it in the lab, where is it, where are you deploying it? In fact, what we showed in the lab is commercial grade hardware that's actually in the process of being deployed. And what I'd say is, our competitors can't even do this in the lab. The best they can do in the field or the lab is hundreds of megabits per second. So this is just an order of magnitude greater than anything that our competitors can do right now. And the radio and the technology that we did it on is actually the stuff that we're deploying in the field. The challenge, as many of you will appreciate, is the devices. We just don't have the devices that really can take advantage of the spectrum. And then frankly, there's a question around the business models. If we're delivering this kind of speed, this is not what your average person is walking around with in terms of a smartphone. In fact, if you're running at 100, 150 megabits per second, the battery is a challenge on the device. So there's a number of things there that we have to work on in terms of the business model, the types of products and services that can take advantage of this, and then also the devices and making sure that it's a user-friendly device with a good customer experience. But we have to get the network out there, and that's what we're working on right now, and then the products and the services and devices will follow. So just to hit the high points, we in fact have devices that are launching really now and through the next 12 months that can take us up to tremendous peak data rates. And then just on the footnote here is what we did in February. Actually, a few weeks ago, we did this 2.6 gigabits per second, which was just phenomenal. And we played around with it as well in terms of taking it up and down, messing with the attenuation. But I should emphasize it's really the sector downlink capacity in aggregate that you get there. So when you divide it among the users, and you got to look at the statistical gain that you get there, but it's a tremendous experience that customers can gain from that. And streaming 4K video is not a business model that I'd advocate. It can drive the tonnage up, but it's certainly, I don't expect customers are going to be wanting to pay what it costs to move this kind of tonnage over the network. So what are the combinations of the technology? And you know, a lot of people looked at, when we first talked about Spark, they sort of said, oh, well, that's just 2.5. It's really not. It's actually all three bands working together, which is very, very important. And it's really TDD and FDD combined. We have both allocations and we have to take advantage of both. The AT8R is also very important for us. And you know, if you look at sort of the antenna, one of the interesting things for us is, you know, high frequency is your friend and your enemy at the same time. And so in this sense, it's your friend in terms of being able to increase the number of antenna elements that you can fit in a reasonable size with an appropriate level of gain to be able to put on a tower. So we're using AT8R for the 2.5. We also are deploying carrier rag capability, and the tri-band devices are really important in order to be able to move between the bands. So you get the capacity and the performance at 2.5, but then you get the coverage and the quality of coverage at 800, and then 1900 is a workhorse for us in terms of the mid-band. So I touched on this before. I won't spend a lot of time on this, but really it's the combination of all those three. What's actually particularly interesting is SoftBank also has a similar spectrum kind of combination as well. They have low frequency 900, they also have 1800, 2.1, and 2.5 spectrum. So when we were putting the partnership together and the relationship together with SoftBank, there was clearly a common interest in how we operate across these different bands as well. There's equal interest in TDD and FDD, and how do we make sure that we've got appropriate customer experience as we move up and down between those bands as well. So a lot of technology sharing there as well. This is the AT8R, and I wanted to show a picture of this, and we did this really for a lot of our analysts who follow us. There was a lot of question around, well, when we come back to our sites and we add 2.5, what's required in terms of the amount of work on the site? And it's really fairly straightforward. This is an example of the AT8R antenna that we have there. That's the radio, and this is the baseband unit. So when we go to a site, this is the Alcatel-Lucent setup. We basically go in, we deploy the baseband unit into the cabinet that we already have deployed. We do have to add another antenna, and then we add another radio on the top of the tower. When we did this, you know, it's really taking advantage of the network vision platform that we put in place. So it's a fairly straightforward upgrade as well. And the infrastructure that we're putting in place actually gives us the multi-layer MIMO capability, but then also we're looking at beamforming as well in order to get a little better improvement and better gain as we deploy this going forward. Alcatel-Lucent's one of the partners we've moved forward with. We're also working with NSN and Samsung as well. So we've divided the business up between the three of them. And we're deploying this into different markets right now. But this is the AT8R and the 8-port radio, and what we demonstrated was the performance running on these live systems as well in the lab. I want to show a little bit about carrier rag. This is very, very important. And there's been a lot of talk about interfrequency carrier rag. The beauty of the spectrum depth that we have in the US is we can actually stack it up in contiguous 20s on the carrier. So we have a combination of lower and upper, and we can basically run 3x20 on both parts of that band. In fact, that's kind of the way we're deploying it. So you can actually have devices that can run 2-3x20 carrier rag. We can set the config so we can actually put a much heavier bias on the downlink, so we can drive the downlink throughput up as well. And this is just an example of what you can get in terms of peak downlink speeds on config 2 with the different MIMO as well as the different carrier rag combinations. So, you know, when you get, and this is really kind of one of the constraints that we have right now, is while we can deliver this on the network side, getting devices that can actually take advantage of this is something we're working on. But we're very interested in, but clearly the performance you get is phenomenal. And what I didn't show there is battery capability, but that's still obviously lagging what we can do for a while. But you know, if you're delivering these kind of speeds, you're not talking about a smartphone, that's for sure. And so, you know, the form factor actually becomes your friend there in terms of the size and the battery that you can put in there, but also the number of antenna elements that you get in there and the performance you can get out of the device as well is there. We also have this mid-band here. There are different requirements on the mid-band, but in different markets we have different combinations of the spectrum. But as I say, generally we have more than 120 megahertz per market, and so we can run different combinations here as well. So it's a tremendous asset that we have, and we're in the process of taking advantage of that. Actually, one